Good afternoon, my YouTube viewers. Crystal here. I wanted to make another video for you, and this video that I'm making today is about the Kaggle Titanic competition. I'm actually on the Kaggle website, and what I've done is I solved the Kaggle Titanic competition just with Numpy, Pandas, and Matplotlib. Truthfully, I didn't really even need Matplotlib, but I wanted to chart something. I wanted to put something on a graph, and because I wanted to put something on a graph, I had to use Matplotlib. But if I didn't do that, I would have been able to solve the competition question with just Numpy and Pandas. So this is the second time I've made this video, because the first time I made the video, I saw that I had made a mistake, and because I had made a mistake, I had to correct the mistake. So I've corrected the mistake, so you're watching the video once I've corrected the mistake. So the first thing that we're going to do is we're going to read the problem statement. The sinking of the Titanic is one of the most infamous shipwrecks in history. On April 15, 1912, during her maiden voyage, the widely considered unsinkable RMS Titanic sank after colliding with an iceberg. Unfortunately, there weren't enough lifeboats for everyone on board, resulting in the death of 1,502 out of 2,224 passengers and crew. While there was some element of luck involved in surviving, it seems some groups of people were more likely to survive than others. In this challenge, we ask you to build a predictive model that answers the question, what sorts of people were more likely to survive, using passenger data, i.e. name, age, gender, socioeconomic class, etc. So that's our problem statement, and now that we've read the problem statement, we'll go ahead and go over the code review for this competition question. And we're actually in the Kaggle the Kaggle page, and whenever I make my blog post, then what I'll do is I will leave a link to the page on the blog post. So if you want the page, you have to read the blog post. So the first thing we do is we load our libraries. We import Pandas, Numpy, and Matplotlib. And as I said before, we really only needed Pandas and Numpy. I only used Matplotlib because I wanted to make a graph. The next thing we do is we load and read the files. So we have three files. We have a train, a test, and a gender submission. And then what we want to do is we read the files. So we read the files into the system, and so we read train and test into the system. So what we want to do is we want to draw the columns. So we made ID train equals train.passenger ID, and ID test equals test.passenger ID. And so we dropped passenger ID, cabin, and ticket from the train and the test file. Then what we want to do is we want to check for null values. We check for null values in both the train file and the test file, and we found out that on the train file you have null values in age and embarked, and in the test file you have null values in age and fare. So we want to impute those null values. So since the age was a numeric file, numeric column, we replaced that with medium. Embarked was an object, so we replaced that with the most commonly used value, and so that was called mode. And then test fare was a float, so we replaced that with median as well. And then what we wanted to do is we wanted to convert age and fare to integers, because I got a 5-point higher score when I converted the age and the fair to integers. So that's why we're making it integers instead of float. So now what we're doing is we're going to pre-process data. And as I said, the only reason why we even used Matplotlib was so we could make some charts. So the first thing we did was we looked to see who survived. And you can see a chart of the number of people who survived. So more people didn't survive than did survive. And then what we've done is we've taken the title out of the name. So when we took the title out of the name, we had 17 titles, but actually there were 18 titles. One of the titles didn't come through. And so we mapped all 18 titles into the column, into the title. And so now we've mapped them. And so now instead of a name, the title is a number, which is what we want. And now what we want to do is we wanted to check to see who was male and who was female. And we put that on a graph as well. So there were more males than females, but more females survived than males. So we mapped the sex. And then when we map the sex, we can see that it's a number, and that's what the model wants to see. The model wants to see a number. And now what we've done is we've taken an extra, we've made a column called family, and what we did was we add the sib spouse to the parent child, and we called that family. So, and then the next thing that we did was we took the embark, and you see that the embark was a 1-letter code. So we put that on a chart as well. And now what we've done is we've taken the letters and we've converted them to numbers. We could have just as easily have mapped the letters as we have done a few times in this program, but I just decided that I wanted to convert them to digits because I wanted to see how do you convert a letter to a digit. And then so we put coding in there to convert letters to digits on the train file. And so we've done that on the train file. And we also did that on the test file. So that's the code to convert a letter to a digit if you want to know how to do it. Now what we've done is we've set up our X and Y values. Y is train survived. And then we set up features. Features is P class, sex, family, embarked, title, age, and fair. X equals train features, and X test equals test features. So now what we want to do is we want to split our test up for training and validating, and we can't use train test split on this because we decided that we were going to use only Numpy and Pandas. So we did the train test split using only Numpy and Pandas. We decided that rows is going to be 800. So X train equals X colon rows. X val equals rows colon. Y train equals Y colon rows. Y val equals Y rows colon. And then what we do is we check the shape of all of these. And you can see that the X train and the Y train was 800 rows. And the X val and the Y val was 91 rows, which is what we wanted to see. Now what we're going to do is we're going to define our model, and we decided that we're going to use logistic regression. And then since that we decided that in this exercise we're going to just use Numpy and Pandas, we had to make logistic regression from scratch, that we could not use a model from sklearn. So we defined a function called sigmoid, and then we defined another function called log likelihood, and then we defined another function called logistic regression. And then what we do is we actually do the weights, and then we actually do the logistic regression, and it tells you how to do it. Logistic regression equals x train, y train, num steps equals 300,000, learning rate equals 5, int 5, and n intercept equals true. And I guess if I had wanted to, I could have increased the steps, and that may have increased the accuracy. We'll never know. Maybe I'll increase the steps and see if it increases the accuracy. So now what we've done is we've trained and we fitted our model. And so when we trained and fitted our model, we had an accuracy of 80.38, which is not too bad. And then what we did was we predicted on our training set, or we predicted on our validation set, and when we predicted on our validation set, we had a 79.12%, which is not too bad, considering all of the other values that I've gotten when I've been working on this data set. So what we did was we created a data frame, and this data frame that we created, you can compare the predicted values to the actual values. So now what we do is we predict on the test set. And so this is our prediction. And then we prepare the predictions. And then we submit the predictions to Kaggle. And what I did was I actually made some changes on this. I made some changes on this program, and I'm not able to get into it at the moment because if I was to press the back button, then it's going to stop the video, which is not what I wanted to do it. But when I originally did it, I had about a 76% accuracy, and so the changes that I made were really minor. The changes that I made were just to add an is null to the test, which wouldn't affect the accuracy. And so that's what I did. So unfortunately, I can't show you. Well, maybe I can. Hold on a second. It's trying. It says look at the latest version. So this is my latest version, but it was about a 76%. If I go here to compete, and I go to the Titanic, and I go to my submissions, I got a 76.79 on that. So that wasn't too bad, and that says 9 hours ago. So that concludes this this presentation for this code review. If you like my videos, please like, subscribe, and share. And if you want to see the most current video that I make, if you tap on the bell button, you will get every video I make. And I make generally one video a day, sometimes 2 or more videos a day. So if you want to receive my emails or receive my videos, then that's the best thing that you can do. If you like the work I do and you want to donate, I will leave my email address to my PayPal account down below. Unfortunately, I do not have enough subscribers, so I cannot monetize. So the only way that I can make money on this channel is if people donate, or if people read my blog post, I'll get paid when they read my blog post. So that concludes this video. Thank you so much for watching it to the end. I look forward to making new videos for you, and I hope you have a very happy day, happy rest of your weekend.